With each new version of ProtaStructure, we extend our reach around the world to support more codes and design practices. ProtaStructure 2024 now supports Colombian and Indian standards for concrete design, steel design, wind loads, and seismic loads. RC beam design, steel design, wind load calculation, elastic and design earthquake spectrum generation, base shear calculations, equivalent static and response spectrum analysis, structural irregularities are included. The seismic parameters are customized according to IS 18993 and NSR 10A provisions. You can definitely expect for more to come in the upcoming versions. We support a wide range of international RC design, steel design, composite design, wind, and seismic codes. In fact, these codes and other code-related settings are automatically selected when you start your project using the template specifically created for India and Colombia. In ProtaStructure, load combinations are generated automatically using an interactive wizard. You can choose options for vertical and lateral load cases, such as pattern loading, construction stage, P-delta effects, RSA, or equivalent static seismic analysis, vertical earthquake, use of cracked sections, and more. The necessary load cases and combinations are automatically created complying with the preferences. You can further edit the combination factors to suit your specific design requirements. The wind loads are calculated according to IS 875 and NSR 10 loading codes. Launch the wind load generator and specify the necessary parameters. The wind loads will then be calculated and assigned to story levels automatically. Besides, you can import wind loads from an Excel spreadsheet. ProtaStructure has a comprehensive user interface for calculating the acceleration spectra using the parameters outlined in IS 1893 and NSR 10A. Select a town in India or Colombia, and related seismic parameters will be fetched automatically. We provide you with the helper tables taken from the code with relevant references, so you are not lost in code. You can select different structural systems in each orthogonal direction to make use different behavior factors, and of course different design spectra. The table here lists the structural systems in IS 1893 and NSR 10A. There are detailed analysis settings such as additional eccentricity, number of modes, user-defined periods, and so on. ProtaStructure will also perform plan and elevation irregularity checks automatically and report them after the analysis. RSA to EQS scaling coefficients, mode superposition method are all customizable. For important projects in India, you will need site-specific spectra. If you have one for the building site, you can introduce it to ProtaStructure as well. Of course, you can always further customize the parameters on this dialog. When you are done, just click OK and proceed with the analysis. After setting the seismic parameters, maybe the most important step is to set the model options that will be used in analytical model creation and building analysis. The model options also play an important role in seismic checks as well. These options are specifically tailored considering the requirements of IS 1893, NSR 10A, and other international seismic codes. For example, the use of cracked section properties in seismic load cases is a crucial step. The effective stiffness factors are compliant with IS 1893 and NSR 10A. On top of that, you can use different stiffness factors for vertical load combinations and seismic load combinations. Proper modeling of shear walls and core walls are vital. ProtaStructure allows you to select between mid-pier and shell models for rectangular walls. Because of their torsional behavior, core walls are always modeled with shell members to reflect this behavior better. You have full control over mesh size. The FE mesh that is compatible with the connecting members is created automatically. Slab and diaphragm modeling is also pivotal. ProtaStructure will automatically understand the existence of multiple rigid diaphragms and free nodes by examining the slab connectivity. You can force ProtaStructure to use a single rigid diaphragm at each story, or no rigid diaphragm at all. If you need to consider diaphragm discontinuities, you can mesh the slabs and use a flexible diaphragm approach, especially in transition floors and floors with large gallery openings. You can use different assumptions for different floor levels. Here you have full control over slab in-plane and out-of-plane stiffness modifiers and inclusion of column outlines in the FE mesh. By the way, vertical loads can be automatically decomposed during modeling or from the mesh during the analysis. The choice is yours. The real power of ProtaStructure resides in creating the analytical model automatically from the physical model. State-of-the-art finite elements and formulations are used. The physical model is segmented and chopped, considering the connectivities, and a fully connected and compatible FE mesh is created for you. All you have to do is to deal with the physical structural BIM model. For example, here you see how two basement floors are meshed together with the first story. Basement and core walls are modeled with FE shell members connected at common nodes. The first thing to look at is the vibration modes of the structure to understand any inherent structural system weak points. For this particular structure, the first mode is a torsional mode, probably because of the asymmetrical position of the core walls. The second mode seems to be a coupled mode in X and Y directions, so it may be a good idea to improve the structural system. We used flexible diaphragm for the basement floors and the first floor. The rigid diaphragms can be visualized after the fourth story. You can have a look at member diagrams including beams, columns, and slab strips. Core wall results are also compiled into a diagram. Automated FE contours can be drawn for in-plane and out-of-plane effects. You can also create user-defined contours, so ProtaStructure allows you to dig deeper in the analytical model details. Seismic analysis is not complete unless you perform irregularity checks and other seismic checks. The post-analysis report includes all the important checks related to IS 1893 and NSR 10A with code references. For example, a drift-based soft story check is done, vertical mass distribution is checked, torsional irregularity is checked, and analysis is automatically repeated with additional eccentricities. Applicability of equivalent static method is also checked. If you have a building with basement, the basement validation is done comparing the upper structure period to whole structure. Interstory drift checks are done, and the prominence of second-order effects is evaluated. Other important checks such as diaphragm integrity and wall-slab interaction are done. A two-stage analysis is performed for buildings with basements, which allows you to use different mass and stiffness matrices for upper and lower structure. Additionally, RSA to EQS comparison and cumulative modal mass participation are checked if you use a mode superposition analysis.